Compiler construction is an area of computer science that deals with the theory and practice of developing programming languages and their associated compilers. The theoretical portion is primarily concerned with syntax, grammar and semantics of programming languages. One could say that this gives this particular area of computer science a strong tie with linguistics. Some courses on compiler construction will include a simplified grammar of a spoken language that can be used to form a valid sentence for the purposes of providing students with an analogy to help them understand how grammar works for programming languages. The practical portion covers actual implementation of compilers for languages. Students will typically end up writing the front end of a compiler for a simplistic teaching language, such as micro-lexical analysis. The first phase of a compiler is called lexical analysis. This phase involves grouping the characters that make up the source program into meaningful sequences called lexemes. Lexemes belong to token classes such as integer, identifier, or whitespace. A token of the form less than token class, attribute value greater than is produced for each lexeme. Lexical analysis is also called scanning. Syntax analysis. The second phase of constructing a compiler is syntax analysis. The output of lexical analyzer is used to create a representation which shows the grammatical structure of the tokens. Syntax analysis is also called parsing. Semantic analysis. Main article. Semantic analysis. Semantic analysis is the final phase of the compiler front end. During this phase, the compiler applies semantic rules to the syntax tree built by the parser. The tasks performed during this phase vary depending on the design of the compiler, but typically include type checking, scope checking and object binding. Symbol tables may also be constructed during semantic analysis in preparation for code generation. In some cases, such as a one-pass compiler, semantic analysis is done at the same time as syntax analysis. History, subfields, parsing, program analysis, program transformation, compiler or program optimization, code generation.